Hi everyone, welcome to my channel and I am Subhash Chandran. In this video, we are going to cover the fundamentals of pipe stress analysis. So without wasting your time, let's get started.
Fundamentals of pipe stress analysis. Being a piping design engineer, one must aware about the concepts of stress analysis. So that will help you to understand the consequences of stress in the piping system. So this will help you to deliver a better package than those who do not have the stress knowledge. So through this video, let me share my knowledge with you. So when we talk about pipe stress analysis, we should aware about the two terms. One is stress and another one is strain. We should have a clear idea about what is stress and what is strain. So let's understand through example. Let's take a glass in your hand and try to compress it as much as possible. So at the first attempt, it will not break. And you put more pressure and more try to compress, and second attempt it may not fail. But if you put all your effort in order to break the glass, it will break. So what does it mean? So when you are giving some force to the glass, at the first attempt it is not breaking because it is holding the force. And the second attempt it's not breaking, and the third attempt when the forces that goes beyond the capacity of that material, it breaks. Correct? This is a simple example I wanted to share. The same thing applies for any other material as well. If you try to compress or if you try to expand, to certain limit it will withstand. But if you put more force beyond the limit of that material, it will break. Correct? So let's understand. What is stress? Stress is all about just a force. Okay. So we have to understand that the stress is all about a force that is exerted upon certain object or a material. Now let's understand about the strain. So in a layman's language, if I want to tell you that strain is nothing but the result of stress. Say for an example, imagine a rod, okay, and you pull this rod from the two ends of the rod. So slowly, to some extent, the rod will hold the deformation, but if you push beyond its limit, it will form a small neck. And if you push beyond the certain limit, actually, it will break over here. So it will form a permanent deformation. So this is known as strain. So stress is nothing but the force and strain is nothing but the deformation. So we have to have this understanding very clear in our mind. We should not get confused. So I think you must have seen this stress strain curve during our engineering college. So this is one of the prominent curve that we are applying in the stress analysis concepts basically. It's very interesting to understand this curve because during engineering we must have understand in order to score marks or in order to just complete the subject. But in reality, we have to understand how this actually works actually. See, this is the curve. And here, the one important thing that you have to notice is that yield point. So what is yield point? Yield point is a point till which the material is fully reversible. Okay. So what does it mean? Beyond this point, the material will not be reversible. So if you put some force to a material and the material can hold up to this point, it is reversible. Say for an example, rod or glass or anything that. If you put X number of forces actually, if the X number of force is not beyond this point, it will not deform. But if the X number of force goes beyond this form, it will deform. That is where it exceeds the minimum capacity of the material actually. This is what we term as allowable in as per ASME B31.3 actually. So this curve at the first straight length up to the yield point is irreversible. But after that what happens? After that it becomes tensile. So it becomes tensile in such a way that it will not break but it will deform. It will change its shape but it will not come back to its original shape. So this is going to be a permanent deformation. So that is known as strain basically. And if you extend beyond certain point actually it will rupture. So there are simple stages. One is yield point, and second one is the deformation stage, and third is a rupture stage actually. So this is the concept we are applying in the pipe stress analysis because piping is always a material which are made of either CS or SS or plastic or anything such, right? FRP or GRP. Every material has its own capacity. If the material strength goes beyond this point, it will break and it will deform. But if you maintain the forces and the moments which are within this particular yield point, the material will not cause any harm and it will not get deformed or damaged. Okay. Now let's get into the core area actually. So this is ASME B31.3 snapshot. So this exactly shows what the concept that we have discussed now and how it is actually applied. See, what is the title of it? This is table A1. You can go and refer the ASME B31.3, the basic allowable stresses in tension for metals. If you look at it, you can see the material and the spec number and everything given. So the one of the key thing that I want to highlight over here is that tensile strength and yield strength. Okay. So if you look at the standard carbon steel material that we generally use is a grade B, which is A106 grade B material, right? So what is the tensile strength of this pipe? It is 60 KSI, okay, and what is the yield strength? It is 35 KSI. So you have to imagine in a way that if any of the forces in the piping system that goes beyond 35,000, it will cause a deformation. So you have to always maintain the forces within this limit so that it will not cause any permanent deformation. So that's one of the very important things. And moreover, if you look at it, for each temperature, it has already given what is the allowable. So the tensile is more and yield strength is much lesser. But if you look at the allowable is much lesser. So our piping systems are designed based on allowable. So even if the allowable goes little bit also, it will not be exceeding the yield strength actually. So that's why one of the most reason why our piping systems are so strong and so obviously working even if you do a lot of mistakes actually. So this is one of the key factor why this is perfectly working. Okay, so you can refer this table in ASME table A1, and now let's go to the next one. So now we are going to understand about what is the triggering factor. So you must have something known as a triggering factor, right? So that will trigger the stress. So let me classify this into two categories. One is internal triggering factor and another one is external triggering factor. So let's first look into the internal triggering factors. What are those? First one is temperature. So in our service, the temperature varies with respect to different services. There are 50 degrees, there are 110 degrees, there are 150 degrees, and the temperature goes up to 300, 400 as well, right? But here what we have to understand is that during any temperature, the pipe material tend to expand. All material in the world tend to expand during the difference of temperature. For example, let's take a 1 meter of a pipe at 25 degree. Okay, so 1 meter of the pipe at 25 degree, and if you compare the same meter of the pipe at 100 degree, it has expanded to 1.2 meter. So the length of the pipe got extended. So this is the deformation for 1 meter. So imagine if there is a 100 meter of a pipe which is at 10 degree and 0.2 mm it expands, so it will be 20 centimeter, right? So 20 centimeter of the piping, if it is going to expand actually, and if you are not able to stop it, it will break the other endpoints, right? So temperature is one of the vital factors. So let me just share you. This is the thermal expansion data which is shown in the ASME B31.3. So the very interesting factor is that if you look at the thermal expansion rate over here, so here let me just define what is it. A, we are not looking at the A, this is coefficient factor. We are looking at the B actually. Linear thermal expansion. What is it? Mm per meter. So this figure is going to be, the unit is mm per meter. So for example, let's take the temperature here starts with 20 degrees Celsius and it goes up to, the variation has been given as up to minus 200 and 275. If you go to the next page, the temperature goes beyond as well actually. But for our understanding, let's take 100 degrees Celsius. Okay, for 100 degrees Celsius, for every 1 meter, 1 mm is the expansion. Imagine for 100 degrees Celsius, for every 1 meter, 1 mm is the expansion. Okay, so for every 200 degrees Celsius, the expansion is 2.3 mm. So imagine you have 100 meter piping. Okay, for every 1 meter it is 2.3. Okay, for 100 meter how much it will be? So it will be nearly around 230 centimeter, right? So 230 centimeter it will get, through 230 millimeter. 230 millimeter it will get expanded actually. So this is, it's not a small amount of expansion, because if you don't manage it properly, it will break the end connection where it is got connected. So this is one of the primary factors in piping. The piping tend to expand. So we have to understand that any piping tend to expand. But if you look at the minus side, actually, minus side also the line tend to contract. Here it expands and here it contracts actually. From 20 degrees Celsius, and if you go minus 50, minus 100, the line contracts up to minus 1 mm. So it gets shrinked actually. So this is how the piping system works. So temperature plays a vital role. So this is one of the major triggering factor. The next one is the pressure. So what is the pressure? Pressure is an internal pressure, right? There are two types of pressure, internal pressure and external pressure. So generally in piping we have an internal pressure, but if there are any jacketed line, the internal piping will have the external pressure as well. So we consider internal pressure is the most important thing. Okay. So here the internal pressure, how it acts? It acts all around the walls of the piping. So at one side your piping is experiencing the temperature where it is expanding, and in the other side there is a pressure inside the piping which is impacting the wall thickness. So there are two dynamics now, correct? Now let's go to the third one, velocity. Velocity is nothing but the velocity of the fluid that passes through the piping actually. Imagine the fluid comes with a certain velocity and it will directly come and hit the elbow, right? So what will cause? It will cause some sort of a pressure, some sort of a force to the elbow. So that will completely change the dynamics of this piping, right? If the impact is more, you may experience a crack over here, and you may experience a crack over here. So if it is not managed properly, definitely there will be a damage in the piping. It's not only in one elbow. Let's imagine the fluid passes through multiple elbows. It will hit over here, 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 and there will be multiple dimensions of the hittings are there, and this will cause a turbulence and the vibrations as well. So velocity, it's one of the key factor. So that will cause the instability of the piping. So now you can imagine temperature is one effect, pressure is one effect, velocity is one effect. If all of these three factors combined together, and it always goes through the piping, and piping experiences these forces in every second in the system. So that's one of the very important things that you have to understand as a stress engineer. So that's how you get the conceptual understanding. Now the fourth one is weight. Imagine piping has got weight, right? It has got a material weight. It has got a fluid weight. The pipe is filled with the fluid. That weight is also there. And it has got a insulation weight. So all of this weight goes where actually? It goes to the bottom of the piping, right? So all of the weight has to be bared by the bottom of the piping. So your wall thickness also needs to be designed in such a way that it will bear. Otherwise it will break. Imagine you selected a piping which is so thin. The wall thickness of the piping is so thin, and the size of the line is 12 inch and 16 inch. Do you think the pipe can bear the overall weight? It will not bear the overall weight. It will buckle. Okay, so that's one of the reason why weight is also considered as one of the important factor while designing the piping system. So these are the internal factors that we have to understand. These are very preliminary internal factors. There are much more internal factors are there, like densities and insulation weights and everything. But here we are just going to understand the preliminary concepts of the stress analysis, because this is far more important than to go into the micro level details for a piping design engineers. Now let's go to the external factors. What are the external factors? External factors are factors that comes from external of the piping system. What is it? Let's get into it. Wind force. Imagine, see, if there is a tall building and the wind is acting from one direction, it will definitely push the wall of the building, right? So eventually what will happen? The building will tend to move, and it will put a lot of pressure on the other side of the building, and it will put a lot of pressure on the bottom of this side of the building, so that here it will expand and here it will compress actually. But throughout the whole the time actually, the building has to swing on left and right actually. This will cause the fatigue in the system. So the same thing applies in the piping. In piping you can see the most process units, the average height is 20 meter. So the wind effects are primarily higher if the height of the structure is more than 10 meter actually. So if you can see at the structure which is more than 20 meter actually, definitely you can experience a lot of wind effects actually. That's why wind force needs to be considered. Otherwise it will cause a lot of failures in the structures, and if there is any failure in one particular structure, the whole thing will be collapsed. So wind force is one of the primary things that you have to understand actually. Then goes to the earthquake. Earthquakes, I don't have to explain you. Earthquake is a multidimensional. it will cause a lot of instability to the entire systems. So if the earthquake forces are not considered, then the piping system is under risk. So that's one of the key reason why in stress analysis earthquakes are considered. And earthquakes are not considered in all the areas. There are some zones are available. There are some safe zones are available where you don't have to consider, but there are some key zones where you have to consider. So those will be designed or defined in your client specification. Accordingly, you have to consider. But fundamentally, as a stress engineer, you have to understand whether the zone is defined as an earthquake zone or not. If it is defined as an earthquake zone, then you have to consider it actually. So you can understand that this area is prone for earthquakes, and you have to consider this factor and design it accordingly. Now let's go to the next one, snowfall. See, snowfall, if you look at the snow, actually snow is solid, right? So it's not weightless, it's solid. So if you find the places where there is more snowfall, the snowfall effect needs to be considered, because it is going to add more than nearly half of the weight of the piping. So definitely, if you are designing the piping system with only piping system weight and not considering the snow, when the snow comes in, drops into your piping, actually, definitely the structure will experience more weight. So it will definitely collapse. So you have to consider it actually. The fourth one is a wave effect. Wave effects are generally not used in onshore because onshores are not in the sea, right? Wave effects are generally used in places where the plants are built over the sea, because the waves is going to generate certain kind of forces that will disturb the piping systems. So this is only applicable in the offshore areas, and but mostly in the onshore, so we don't have this wave effect. Now let's understand the line behavior study. Actually, this is primarily important for any piping design engineer to understand. You don't have to do stress analysis in the softwares actually, but as a conceptual you have to understand. Let's take a line, okay? So let's take a line that runs this way and this way, okay? Let's consider this is a straight line with an elbow and it comes down, okay? Let's imagine the temperature of the line is 180 degree. So what do you think the expansion of the line is going to be? How does the pipe will move during the thermal expansion? Let me show you now. This is how the pipe will move. The pipe will not move in a linear way. So here you cannot imagine the pipe will move in a straight line. So during thermal expansion, because here it is connected, right? So it is not a free. This one end is not free. The line may be turning here, it goes up actually. So since it is connected, the line will take that as a restraint and it will move on the opposite side. So this is how the line going to expand it at any case if you have a bend like this actually. So how do you going to control it? So this is why you have to understand the stress analysis. In stress analysis, people used to put multiple rest guides in order to limit it actually, because if the expansion is more, it will hit the nearby line, correct? So you have to limit the expansion. At the same time, you cannot prevent the expansion. See, expansion naturally has to happen. If you are going to stop this expansion, this will the line will get compressed within and it will get damaged actually. So you have to allow the expansion, but make sure it will not hit the nearby line. So accordingly, you have to provide the support actually. Let's understand from the different way. Let's take a straight line. Okay, the straight line, as I said, in any temperature, it will expand. So imagine this line has expanded up to here. If the same line, if I'm going to put an anchor on two locations, let's say over here and over here. So what is anchor? Anchor is something that will arrest all degrees of movement. So it is going to be completely arrest the movement here. So at this point and this point, the line is completely arrested, right? So the pipe has no place to move actually. So slowly what will happen? It will buckle actually. It will buckle over a period of time, and slowly, if the frequency of the buckling increases, because the the line temperature goes at times 80 degree and 50 degree, again it will go to 100 degree and 125 degree. So when the variation comes actually, so slowly this will cause a fatigue and a permanent deformation, and the line will not come back to its original position. So this is one of the key important. So if you arrest two location of the line in a straight line actually, the line will be buckling, so that it will cause a tremendous damage to the material of the piping actually. So this will try to expand, and over a period of time the deformation will be permanent, and there will be a fatigue and there will be a rupture of the material as well. So this is the very important thing that you have to understand for the temperatures actually. Now let's see how the expansion loops works. See, this is how the expansion loops works. Imagine the blue one is the line without any temperature, and when the line goes up to 180 degree, see how the line has behaved. This is how the line has behaved. This is the actual dynamics of the piping. So the during the process plant, when the temperature is high, actually the line will always expand in this way. So this is why you have to limit the put the stress anchors, put the guides, put the rest in such a way that your line is not going to go beyond the allowable. I told you right in the beginning of the video, the line, if it goes beyond the yield strength, it will get damaged. But where in ASME we have the another level of loads which is known as an allowable load, which is lesser than the yield strength. So stress engineer, what they do, they put multiple supports here and there to ensure that the expansion is given. At the same time, the stresses are not gone beyond the limit. Even if you freely allow the expansion, this will cause a lot of deformations. So you should actually limit the expansion and at the same time limit the load as well. But this is the reality, guys. You have to have this in your mind, so that while you're designing the expansion loop, you will be able to visualize how this will behave and how you have to put the support. Now let's go to understand what is force and moment. See, we were talking about the triggering factors. But what this triggering factors actually does? See, the triggering factors such as temperature, pressure, and as well as weight and velocity. All these are certain forces, right? These forces are going to act in the piping at every point of time. So this will act. See, there are generally the forces are defined in three planes: plane 1, 2, and 3, right? X, Y, and Z actually. So the combination of temperature, pressure, and velocity and weight, this will act in these planes continuously in every point of piping. Let's say you have an elbow, T, or any sort of a bend or anything. Continuously, each of the point, the forces will act. So the pipe will be subjected to tremendous forces at every point of time. If the forces are less, the pipe will survive. If the forces are more, the pipe will not survive. So this is about the forces actually. What are moments? Moments are rotational forces, which is the result of the force. Say for an example, let's consider this axis. Okay, so if you experience a moment in this axis, which means that you have a moment over here. Say for an example, if this is where you have a moment, that is the result of these two planes. So X and Y. So if you have a force over here, actually this plane, this will cause a twist, and that will twist to the Z actually. Likewise, if the forces in the Z and X is more actually, and this will act in such a way that it will twist the Y. So the moment is a result of the forces in the other planes actually. So the forces and moments are equally important. You know why it is? Because the moment causes the twist. So more the twist, and it will damage the piping, correct? Because the twisting causes the damage of the pipes. So the pipe will get twisted and it will break as well. So the forces and moments both have to be within the limit. In stress analysis, while we do stress analysis, we used to check whether the forces and moments are within the limit or not. So that's where we have to understand the importance of the forces and the moment. So these forces and moments are the results of what? The temperature, pressure, and weight and velocities, right? So this is how the concept actually works actually. Now let's go to how this is actually impacting the vessels. See, we have talked about the forces in the piping, okay? But when it comes to a nozzle, the nozzles are a critical point in any equipment, right? If the nozzle fails actually, there is no option to continue the plant, because the nozzles are placed in the equipment. Equipments are too costly. If you have to take the equipment for repair, you have to stop the plant, because equipment is a very big vessel where there will be accumulation of lot of fluid. If you remove the equipment, you will not have a standby equipment actually. So it's really important to save the equipment. See, this is an horizontal vessel. This is a descent vertical vessel. Okay. See here the nozzle. So you have an axial FA and FC and a longitudinal FL. So moments also, you have a torsional moment, and you have longitudinal moment, and you have circumpositional moment. So here you can understand. See, the longitudinal force is over here, but the longitudinal moment is over here. That is why it is because of this force, here there is a rotation, and here because of this axial force there is a moment of rotation, and this moment of rotation because of the torsion that comes from these two axes. Okay, So basically the moments are the result of the forces on the other two planes that you have to understand. Say for an example, here FC is there, but here the moment is there. That is because of these two planes here there is a moment. If these two planes moves and revolves around this side, automatically there will be a rotation over here, right? So that is what I'm trying to explain from this picture actually. So this is the kind of a force that acts in knowledge. This will act in every nozzle. So every nozzle in any equipment or anything is subjected to such forces and moments. And if you don't save it, it will fail. Okay, look at the dish end side. The same philosophy applies actually. You have a longitudinal force FL, and you have circumferential force FC, and you have axial force FE. Likewise, you have the moments also. So how does this moment works? You can see here it has been plotted. See, the result of the torsional force over here is a result of FC and FL. Because if there is a moment over here, if there is this force is acting on this way or this way, this will slowly twist over here. This twist is happening over here. Okay, so this is the rotation that happens over here. Likewise, if you have a moment in the longitudinal axis, that is the result of FA and FL. So I don't want to get into complicate the things actually. How you have to understand, every nozzle of equipment will experience force, moments. You have to limit the force and moments by controlling the thermal expansions, by providing a lot of supports. This is what stress engineer generally does actually. Now let's understand what type of the supports generally stress engineers are used to put. There are rest. Rest means simply supported from bottom, and guides. Guide means the supports are placed on either side of the pipe so that the guide will not the guide will not allow the pipe to move freely. You can provide some gaps actually so that you can allow certain expansions. And hold on. What is hold on? Hold on is the support that will not allow the pipe to lift. Anchors. Anchors is a support where it will arrest all degrees of freedom. It will completely arrest the piping at one point. What are hangers? Hangers are spring supports. There are spring supports. There are rigid hangers. Hangers are either from bottom or top as well. And limit stop. Limit stop is a support that will restrict the movement of the piping in the axial direction. So that is known as limit stop. So there are n number of different types of supports are there. These are the different types of supports that stress analysis engineer primarily use it in order to handle the overall piping system. So now let's see what are the expected failure. Expected failure is that if you take any pressure vessel, you will be able to find such nozzles, right? These nozzles are prone for such failures if you don't handle the force and moments properly. This is not only applicable for the pressure vessels, it is also applied for the critical equipment such as pumps. Because pumps are considered to be the critical the rotary equipments. So if you don't consider the forces and moments that are actually passed on to the nozzle of the pumps, so you will not be able to save the pumps. Okay, so you have to limit the forces and moments which are which goes to the pump nozzles basically, and it also applies for the compressors also. So there are critical compressors are one of the critical equipment in the process plant. Compressors, turbines actually. So these forces will actually not only damage the equipment nozzle, but it will also cause a misalignment in the compressor shaft also. So it's very important to understand the loading and forces and moments of the equipments of particular point so that you will be able to handle it better well. Okay. So from the stress analysis, what are things that you generally review it? See, in stress analysis, we review nozzle loads, we review support loads, we review vibrations with thermal expansions, high stress, flange leakage, and line sagging. So these are the various factors primary factors that we generally review in the stress analysis. Nozzle loads will, by reviewing this, you can understand whether the nozzle load in the equipment is more or not. If it is more, then you will you check the piping supports and check the routing, how you can minimize the loads. Likewise, if the support load is more, actually you have to distribute this load to somewhere else actually. Try to put more supports on the nearby line. By increase the number of supports, you can minimize the support load as well. So likewise, you have to plan various things like vibrations, like thermal expansions. You can restrict the thermal expansion so that the line will not hit the nearby line. So you can see whether any part of the piping has high stress or not. So you will improve the flexibility of the piping in such a way that you can minimize the stresses. And if there are some lot of movement in the piping, the flanges in the piping system will get leaked. So you will ensure that the high rated piping has a leakage or not. So thereby you can ensure the safety of the piping also. And line sagging, if there is a more line sagging, definitely that will cause a deformation over a period of time. So these are the primary things that you have to understand and you have to verify in the pipe stress analysis. So that will help you to ensure that your piping system is safer. So generally, the stress analysis, we will not have any simple lines, right? So we'll have a lot of complicated lines which has a different dimensions. Consider the line which is shown in this picture. It has got elbow here, and then it goes up, and then it goes up again, and this one got a lot of branches. So if you look at the forces of x and y dimension and z dimension moments, actually here the dimensions of this application of the forces is too complex to understand. So at one side it will have another on the different side, and this side it will act in the different side. So the combination of the analysis of the forces manually, it is not possible because of the dynamics of this action, that is the how the forces and moments actually works actually, because it is not linear, right? So it is the routing is changing, it is taking a direction actually. So if you find one force over here and you will find another force over here. So this is why the software has been designed with a lot of iterative formulas and calculations that will help you to calculate the forces and moment at each point of the component, like flanges, elbows, and straight pipes, and branches, and valves, and everything. So software will consider each and every point in order to analyze the force and moments, so that you will be able to understand the each and every part of the piping system is safer or not. So generally, let me just tell you the most prominently used softwares in the industries actually. So CZ2 is by Hexagon, which is prominently used across the world actually. But this is not the only software which are used in the industries actually, though it is a prominent one. Say for an example, 60 to 70% of industry uses this one actually. And then you have an auto pipe, and then you have a CAE pipe, and Row2, and you have a PEPS, and you have fast strat proof actually. So you have lot of the softwares that you can learn. Almost all the softwares materials are also available in online to learn actually. But essentially, concept is very important. See, if you understand the concept, then you can handle any software. Say for an example, if you understand the pipe stress analysis concept, you can easily handle the CZ2, you can easily handle the auto pipe, because you know what to be considered, what not to be considered. You know where to analyze and where not to consider. You know how to provide the supports, how not to provide the supports. Okay, so that is very important. Subject and the design and concepts are very important rather than focusing on software. Software is also very important. I'm not saying because that is a tool where you will apply. But at the same time, you need to have the fundamentally strong subject knowledge. So that's where it is very important to understand the concepts of stress analysis. Hope this video helped you to understand a bit of pipe stress analysis concepts. I will meet you in another fantastic video. Until then, bye from Subhash Chandran.